Tyres aren't just round black things on the corners anymore. In fact, research and development over the years has seen wheels and tyres become more sophisticated now than ever, with innovations in strength, weight reduction, rubber compound and tread design. Is the most significant part of the tyre's construction. Coupled with the profile, it impacts on overall tyre performance. The tread's responsibility is to remove water from between the contact patch and the road surface, while at the same time increasing directional stability and eliminating the potential risk of aquaplaning. An open tread pattern has the ability to push more water from the contact patch, but has a higher void ratio, meaning less rubber contacting the road surface, thereby reducing the tyre's life. Whereas a closed tread must work harder to disperse the water. With a lower void ratio, the tyre's life is extended due to a larger surface area contacting the road. Passenger vehicle tyres are always a compromise between endurance and grip across all weather conditions. Tyre manufacturers incorporate sipes or kerfs into the tread block. These may appear as a slice or cut. They are designed to open and close as the tyre makes contact with the road surface. Sipes help the tread block break the water's surface tension, improving wet weather adhesion while at the same time reducing road noise. With major advances in engine and suspension performance, directional and straight line safety at higher speeds have become a must. Tyre manufacturers now incorporate a solid centre tread section, providing the tyre with greater directional stability under these more extreme conditions. A tyre with an open tread pattern has a better self-cleaning ability compared to a closed tread type. But a wider pattern does have some trade-offs, including noticeable tyre noise and increased rolling resistance at lower speeds. As a general rule, soft compound tyres provide exceptional grip and complements the suspension and braking systems, but does suffer a much shorter service life. A hard compound tyre will offer extended wear characteristics and acceptable wet and dry handling, although may fade when pushed past its design limits. A tyre's tread depth is measured from the tread face to the tread base. When measuring, care must be taken to avoid the tread wear indicators located here. As a guide, a wear indicator rises about 1.5mm above the tread base. VPR, or variable pitch ratio, relates to the difference in size of tread blocks seen on a tyre. This variation reduces the harmonics produced by the rotating tyre. Tyres should be inflated to the pressures recommended by the manufacturer or as shown on the tyre placard. Correct inflation holds the tyre in its exact shape, with the tread making full contact with the road surface. An underinflated tyre loses its shape, so the edges of the tread will be in heavy contact with the road, while the centre patch of the tyre remains untouched. Overinflation will see the tyre swell, reducing the tread contact patch area and causing excessive wear. Incorrect tyre pressures, whether it be under or overinflation, results in harsh suspension feel, reduced cornering grip and prolonged stopping distances. Wheels come in many styles and designs and are primarily made of steel or alloy. Alloy wheels have been adopted for use in passenger and performance vehicles due to their weight savings over steel. The main advantage for these designs is the reduction of unsprung mass, resulting in braking, steering and suspension improvements. Most steel wheels are manufactured using a stamped outer rim section with the centre wheel mounting flange welded into position. Steel rims are heavier than alloy, but are cheaper to build and easy to repair if damaged. Split rims are more commonly seen on heavy vehicles. They use a steel rim and a steel locking ring to secure the tyre. 2 or 3-piece wheels are usually constructed from alloy or a combination of alloy and steel using an interchangeable centre, outer barrel and rim. These are mainly used in performance or show car applications. Whether steel or alloy, modern-day wheels share similar designs encompassing safety and service. There are multiple components that make up these assemblies. The outer rim ensures an airtight seal and supports the full weight of the vehicle. The centre flange is attached to this component. The flange or spindle holds the rim to the vehicle using a number of retaining nuts or studs, and houses the centre bore, which supports the vehicle's weight via the hub spigot. The centre bore may use a bush or spacer for ease of location on the hub. The drop centre or well is there to facilitate fitment or removal of the tyre. Wheel rims may incorporate integrated safety ridges, manufactured as part of the assembly. Located adjacent to both bead seats, it helps prevent the tyre from dislodging if it loses substantial air pressure or is subjected to extreme lateral forces. Holes may be drilled into the rim, locating the valve stem and tyre bead locks. PCD, or the pitch circle diameter, refers to the diameter of a circle drawn through the centre of the retainer holes. The first PCD numeral indicates the number of studs, while the second refers to the spacing of the holes. This is typically measured in millimetres. When fitting aftermarket rims, ensure the PCD is correct. An incorrect PCD can cause vibration, instability and poor braking. The true centre line is the exact centre of the rim's width. The total width is measured between bead seats. Backspace is the distance from the rear rim face to the mounting flange. Offset is the distance between the true centre line and the face of the mounting flange. Changing the offset by a relatively small amount is acceptable, but any large alterations will affect steering angles and the stability of the vehicle. Increasing the offset moves the rim assembly closer to the suspension, whilst decreasing the offset moves it away. Steel and some alloy wheels are typically mounted using tapered seat nuts. These wheel nuts have a tapered face that is placed towards the rim and fit into a matching seat to help centre the wheel on the wheel studs. Generally, only alloy rims will use a stepped or mag seat wheel nut. This type uses a flat washer mounted on the shank. Ball seats are ground on a specific radius. These retainers are suitable only for wheels that are machined with the same radius seat. This type of seat is common for Euro-spec vehicles. Wheel bolts are a combination of both the stud and nut. They may be designed as tapered, flat or ball seat, and are again predominantly seen in European marques. Different wheel nut and bolt designs should not be interchanged, as this may be detrimental to the wheel security and vehicle safety. All wheel nuts have a correct tightening sequence that must be followed. Incorrectly torqued nuts or bolts may not be secured and will result in dislodgement during operation. Failure to follow designated fitting procedures may also cause brake shudder or even strip the stud and nut. With wheel and tyre technology advancing, in conjunction with steering, suspension and brake systems, we need to make sure our knowledge in this field evolves so we can stay ahead of the game. Thanks for watching. See you soon.